Okay, let's continue with the computational point, because I was having a little bit trouble with that recording. So what I have done, I have just added this CPA 7, CPA 8, 9, and then I have started there at the very upstream of this reservoir, okay, CPB 0. So now if I just put this one, click on this black dot, and here this will be CPB, like CPB 1, because these are close to reservoir B. So now this one will be CPB2, CPB2, and this is at the intersection or junction. We're done here, and then that will be like CPB3, right? CPB3, and this is also at the junction, and we're done. So this will be CPB4, and then we have another junction there, CPB5, and this is at the junction, and we have outlet at the very downstream, so that is going to be like outlet, okay, outlet, and it's done. So you're done with inserting all this computational point, and you can even miss some of them, okay. You don't need to even insert at every junction or everywhere. The model will automatically detect, and it will become red when we'll add our next information as well, so we don't need to be worried about that one. Okay, so we are done with this. So what we are going to do now, we have to even create a configuration file. So if you even go to watershed, and then you'll see a configuration editor, you can open that configuration editor and then click configuration and then new. Okay, so that will be standard configuration. Okay, so I'm giving the name as standard config, and the time step. So if you have data like hourly, you can give the hourly step. If you have daily data, this means the boundary condition data, you can give daily. It doesn't matter. So I have hourly data, so I'm giving hour, and then it's done. You can select today's date, the base date. It's done there. Okay, everything looks okay. You can give any description and then apply, and then okay. So you have the configuration file. You can see now you have this configuration. Okay. So from this configuration, if you want to even change anything, just you can even click there and select any reservoir, anything you can do. Okay, you can select and you can right click, you can go to the property, you can change the name and rename, anything you can do. So definitely will do everything. You can see the property and everything. Okay, so these are the reservoirs we have, and now we have to even save our reservoir. So from watershed, and then we have to save the saved configuration. Okay, so if you set the configuration, or watershed configuration has been saved. Now what we have to do, we have to move to our next important module, Reservoir Network, and we'll even import our dataset as well. So I'm clicking on Reservoir Network. So it is gonna ask you that, okay, do you want to save it? Okay, of course, why not? So I'm saving that. Okay, so we have this river network. So here what I have to do, I have to even connect this node with this node and everything using our reach tool. Here we can see we have a tool called reach tool, and this reach, because if you put any inflow there, this inflow needs to be carried using any routing method. If your these nodes are very close, then you don't need any routing. So this water will be directly transformed here and transported there as it is. If you have a long river, then this amount won't be there. It will take a time, right? It will take time to go there, and then it will even lose some amount of water. It will be even superimposing with this one at a later time, so the peak will be changed. So that's why you need to use any routing mechanism. So we'll check that, but for this case we won't use any routing, because you need to even calculate if you want to use masking gum, and if you have data for that, you can use that, and we have different routing mechanism there as well. We'll check that. So now what do you have to do, this is our network, so go to network and create a new network. Okay, so here you have to provide the name as network, or any name you want, network, and you can give the description and the configuration we have. We are going to create this network for this configuration, this watershed configuration we have. And if I click OK, so now we have this. See, or automatically you can see all the black dot previously we had, right, the computational point, now they have become red. So these are the point. Here you can see these are called junction tool. So at this junction you will have your simulation data, or you can even use this junction as your boundary condition inflow, right? If you have flow from this junction, automatically it will generate everything. Okay, and now what do you have to do? You have to even generate your reach. So clicking on that, click on this reach tool, and again as before, control and click there from upstream to downstream, and then it will automatically select. So the name you can change, or it is automatically giving the name. So for the time being I'm keeping whatever it is, and it is showing the direction of flow, right? So I'm just clicking there and connecting everything. I'm continuing, and okay, so I'm continuing from upstream to downstream. Okay, so this is how you have to even connect every stream. You can exclude some of them, it doesn't matter, but if you have time and if you need to just develop the model as a detailed one, even you may have more complex river network, it doesn't matter, you can and do that. It will take time, but I'm just quickly showing you. Still it's taking a long time, and before doing that definitely you need to have all your data set ready so that you can easily import. So I just already generated those data set, I'll show you. And here we have many points. So from this point, okay, let me connect that part as well. Control, and then it's automatically giving the name. I'm connecting pretty simply, and then here as well. So from this point I'm connecting this point, it's done. Okay, let's connect this one with this one, and then finally here we have another one, this one with this one, and here we have this one with this one. Connect everything, then it will look good, and you'll have all this computation. This is like upstream to downstream. That is the rule to determine, and you can't even avoid any junction. You have to even connect all these junctions together, then it will automatically connect, otherwise it will not connect. Okay, so I'm almost done, and I'm done with this. Okay, so that's the connection we have, and if you want to even edit anything, you can do that. You can click this cursor, and then you can click, and you can change and edit the properties and rename everything. You can delete it, you can do whatever you want to do. Okay, so now this is the most important part. What we have to do now, we have to even click on the reservoir. Now it's the time to edit the reservoir properties. It's time to provide the reservoir properties and data set here. If you right click and open the reservoir A, and you have also access to reservoir B as well. So here the physical property we have the pool level, right? If you know, for any kind of reservoir you have that pool level, and you also have that conservation level, you also have that dead water zone, right? So for example, if I just search any storage reservoir, okay, any section, okay, section of any storage reservoir, and you can see there will be lots of images I can show you there. So for example, here, that is the most important image I can show you. You can see that image is going to show you that searcher's level, and that is the maximum pool level. Then it will just overflow, right? So we are talking about this level, and you also have dead water zone. You also, so this storage zone, we call this one as conservation zone, and then you also have flood control zone. You also have this. So it depends on the purpose of the reservoir, and you also have other even sections as well. You can check, for example, this one. So this one has that description, details description. You can see maybe it has that. Yeah, so these are the calculation you need. There will be a lot of calculations and everything you need to even do. So you can search and you can check, and then we can go back. So here as well, that is even giving you this. So that is the flood storage capacity, that is active storage capacity, and dead water, right? So you have to know this level. So for our river, we have a dam. The maximum dam level is 100 feet. Okay, the elevation, I'm talking about the elevation. So here we need to know this. Okay, the pool, click on the pool, and when it is 0, the elevation is 0, then the storage will be like 500 acre feet. And then I'm considering the maximum elevation. These are the data, these are not real data, so I'm giving this, I'm assuming this. In future videos I'll try to design a specific, I'll get the data from a specific dam. So this will be like 20,000. Okay, the storage will be 20,000. So you have to even calculate this storage from your bathymetry of the reservoir, or from a dam, from DEM data. So this is the pool condition, and then if you click on the dam, you can change the name of the dam, right? And you can put the total elevation, because this is the elevation of your weir or spillway, and then that is the length of the weir or the spillway. So what you have to do, right click and then add different tailored elevation, different thing, leakage or controlled outlet. So this is the gated structure, it is controlled, so I'm gonna add this control outlet. So for this control outlet, when it is kind of elevation 0, then the maximum capacity will be same. Okay, the maximum capacity should be same, it is gonna be 10,000, and then when it is like 100, so capacity should be same. So that is the condition we have. So these are the information you need to know for any reservoir. So we added this reservoir, and I can even apply. So for this reservoir, we also need to even add this operation. See, this is the rule curve, how to operate this reservoir. And if you want to even open a new operation rule, so click on operation and then reservoir A. Okay, this is for reservoir A, and you can describe what is the rule, and then you'll see that flood control, right? So what will be the elevation of the flood control for reservoir A? So I'm gonna, and what will be the date? 1st of January, the initial, at the very beginning of the simulation time. Out of 100, I'm gonna give as 90 feet. Okay, and then for conservation level, I'm gonna give as 75 elevation, and then for inactive, this is the dead zone, and you can even change the name as well. I'm not gonna do that, I'm keeping it as it is. So 50, okay, 50 or 40, whatever it is. It is gonna give you all this information there all together. You can see the red mark, and you can see also 75 and other stuff as well. So for conservation, 75, flood control, it is missing, so again check that, 90. So now we have 3. Okay, so we're done with reservoir A. Now even if you go to reservoir B, so go to physical and then go to reservoir B. So again you have to put all this information, but for the time being I'm gonna give the same storage. Okay, same information I have, it is 100, and then it will be like 20,000 when it is at 100 feet elevation. So I'm done with this, and then go to operation for reservoir B, right? You have to even generate another set. So reservoir B, this is the rule. And then 1st of January you will have this 90 feet, and then for conservation this will be 75. I'm just giving the same, but if you have different information for different reservoir, you can give that name as well. So here it is, right? I'm gonna apply, and then you can see this. Okay, so if I click OK, now your reservoir informations are done. Here you can see, right? Right click and then you can edit, and you can see the information for this reservoir as well, and you can also see the reservoir A as well. So I'm done with this one. So another thing we need to know, and see, if I want to click on any stream or river, you can click on edit risk properties, and you can see here it is, right? And you can see the routing, which routing method you're going to select. For this one, null routing. So we're considering there is no routing. So the amount of water it will be here, directly it will be transported to this point, so without considering the loss or any other cases. And if you want to add losses, you have to give this loss curve and everything, and then if it is constant, give the loss. This loss will come from like evapotranspiration and any other loss or evaporation for river. And then if you want to add any CFS function like infiltration, so that will even decrease with time or whatever it is, you have to know the information, right? The piping or anything. So if you have any observed data, if you check that, you have to add those observation data. So in future videos, I'll add everything. So now routing, I'm not selecting anything, but you can have this option. You can select coefficient routing, Muskingum and Muskingum-Kunz. So if it is 8-point channel, you can even see the user manual. You can see the calculations there, and you have everything there, modified pulse, everything. So for the time being, it's nothing. Okay. So that's that. So these are the reservoir network. We are done with the reservoir information. We're done with connecting these nodes and junctions. Everything looks okay. Then one thing you have to do here, you have to even click on alternate. Okay. And then you have to click edit. Then you have to create an alternate configuration. Okay. So here, go to alternate and create new and give the name as alternate. So here we'll provide the time series and every information we need. So for this one, the network will be the river network, and then see we have everything there. And then the time step, if you have hourly time step as your input data, you can give that as hourly data, and then you have other option as well, right? So the flow computational method, this will be program determined, and you can use other step as well. And here alternate method will be standard, yield analysis, and Ensemble Monte Carlo. So for this one, we'll use this standard method, right? So here this run control will be 1 hour, and then the operation for reservoir 1, we already set the operation rule, right? Reservoir A and reservoir B, the rule is set, it is the reservoir B. And then look back. Okay, look back information. So for pool, see for this reservoir B, the pool elevation, right? That is gonna be like 75. This is the look back information. Previously it will be this. And then for reservoir B, the look back storage, this will be from computed, so we don't need to import anything. But reservoir A, the pool elevation, so this pool elevation will be what? This pool elevation will be again 75. And then this release, okay? This release controlled. But what we have done, see, we didn't even add that, okay? So we didn't add it. So let me cancel that. So for reservoir B, probably right click and edit. See here, the physical properties, we didn't add if it is controlled or uncontrolled. That's why we are not getting that, okay? So add the control outlet and then give the same. When it is like 0, the capacity is the same, like 10,000. When it is like 100, give the same capacity, like 10,000, okay? So that is what we're not getting this information there. And now if you even open that alternative, and then again, if you just click new and give the same thing, alternate, okay, and then this. So as before, you can select everything there, and time step is like 1 hour, and then operation, you have to even select this one for reservoir A and reservoir B, and then look back. So now you will have this 75, and the constant just give 500, because this is the release 500 CFS, and for reservoir A, I'm giving the same elevation 75, giving the same release as 500 CFS. Okay, so that's that. And then you have to add the time series, this time series, right? So this time series, you have to add all these time series. So I'm just saving that. Now I'm just saving it for the time being. It's already there, and you have to even add all this information. But before doing that, what we have to do, I'm closing it, and then you have to add your inflow points. So these are my inflow points, right? So these are my inflow points. So you have to know the flow information. So I already know the flow information at this location and here, because for operating any reservoir, you have to even calculate the capacity of the reservoir. How to calculate the capacity of a reservoir? You need to know the inflow to the reservoir and then the demand. If your inflow and the demand is different, then the difference between these two, the maximum difference between these two cumulative curve will give you the capacity of the reservoir. So you have to calculate all this information beforehand, but for the time being, I'm just giving you the information and completing this model. So click there, right click, and then if you just edit, okay, the junction, and here if you click on local, and then if I add this inflow at, okay, inflow at that upstream of reservoir A, right, US or reservoir, inflow at reservoir A. So that is the description you can give. And what will be the factor? Means if I import any time series, so since there is nothing coming from other streams, so the factor will be 1, right, since we are not getting any outflow. But for here we have inflow from other streams. So apply, so it changed the shape, see, and then we can even add the flow. And here, because this is from the same sub-basin, so the flow will be divided. So I'm giving this as 60%, and that one I'll give like 40%. So this is inflow at CP, right? CPA1, and the factor will be like 0.6. 60% of flow I'll provide, and I'll get from a sub-basin that will be divided this way, and this one, and then because when I'll add, I don't need to even consider what I'm adding, right? I'll add the same time series, and then it will automatically divide everything there. So that is CPA2, and this factor is gonna be 0.4. So I'm done with adding this one. So for this case and for this case, so add the same thing here, inflow, okay, inflow at CPA6, and the factor will be 1, because whatever I'll add, it will add there, and this is also will be same thing, inflow at CPA4, so that was CPA6, so this is CPA4, the factor will be 1. So here it is gonna be the same thing, CPA5. You can give any name, inflow at CPA5, the factor will be 1 as well, and then we are done with this part. And here we have another right inflow to this reservoir CPB0. So inflow at CPB0 means upstream of the reservoir B, and the factor, of course, it will be 1. Everything will flow into this reservoir, and we have another outlet there, and that will act as inlet, because this outlet is for any sub-watershed, okay? So that's how it will work as inlet to this river. So that is CPB1, and the factor, of course, it will be 1. So here it is, and then I'm gonna give this one as the last one. So that is inflow at CPB4, and of course the factor will be 1 as well. So I'm done with this, okay, river network. I'm done with this river network as well. Even you can save it, and then we're adding this alternative there. So when I'm adding, see, I'm done with adding other stuff, look back, operation, everything looks okay. So only I have to add the time series. If you need to know which one is which, you can just explore it. I have this reservoir A, I didn't add this name, so that's that. So here you need to create the time series of your inflow as a DSS file. So in my future video, I'll show you how to create the time series in the DSS file, right? That is called data storage system in HEC software package. So you can automatically read those data. So I can add the path name, so select DSS path, and then I'm gonna open it. If I go up then I can see I have this data here. The first one I have here. Okay, I'm just opening this data set. I can see, and I can even plot and check the data. See, it is looking like this. I have this data set from 1993 to 2017. So I'm gonna even model for the storm Harvey that like occurred in 2017, in August 2017. So I'll just run for this part and we'll see. Okay, I'll run the model for 3 months. So this is the data set I'm gonna add. Set path name and see it added. If you just click there, set path name, it is just adding. Okay, because I have other data as well, but I'm adding one time series to make it simple. But for your case or for any specific model, we have to even determine the flow differently and separately. Okay, so I'm done with adding. So here alternate and then save. So these are the options we added. We're done with this. Okay, so what I can do, I can save it. Okay, I can save the river network. So that is the second part of this tutorial, and in the third part, what I'll do, I'll create the simulation and then I'll visualize the results. Okay, so that is what I'm just finishing up here as the second part of this tutorial, and then we'll see in the next tutorial how to run the model and how to visualize and explore the result as well. So thank you very much for watching, and thank you for supporting this channel.